Esters are made by combining an alcohol with a carboxylic acid. This is an equilibrium reaction. Esters are produced when carboxylic acids are heated with alcohols in the presence of an acid catalyst. In our reactions, we've been using sulfuric acid. This process is slow and reversible, and you can see that R represents any length carbon chain. An example, as shown in this equation, is ethanol with ethanoic acid. What about naming? Naming esters requires you to have a look at the alcohol and put a Y, and the acid and put an OH. This is a dangerous practical. There are highly flammable liquids. Wear your safety goggles and the rest of your protective equipment. Make sure that you have an open top without a stopper. The liquids are highly flammable. And when you set up your distillation kit, make sure the glassware is tight. Loose-fitting distillation kits can cause fires where the joins are. Remember, safety in the lab at all times. Reflux is an important part of making an ester.
But why not just mix the two chemicals together, not even bother about heating?
It's all about orientation. Because the molecules need to join at the end of the carboxylic acid and at the hydroxyl group of the alcohol, we need to make sure that we have high activation energy. Because the molecules are highly volatile, we need to make sure that they're in a condenser, and this makes sure that we do not lose any of the reactants or products. The sulfuric acid acts like a catalyst, lowering the activation energy and reducing the amount of time that reflux is needed. This is an equilibrium reaction, so if we add excess of one of the reactants, it's going to force the reaction towards the products.
Water into this one. This one will be organic. What's gone in there, Aaron?
20 mils of distilled water.
What's the purpose of that?
To determine what is water soluble. This is going to be awesome.
Ready? We don't want any boiling chips in there.
That's going to be an error, isn't it? That last bit. You can't get boiling chip. Am I right? I'm right, aren't I?
Because you're going to use that up.
Well, there'll be some lost there.
Rightio.
Look at that. They're going to shake it. That's a big plug.
What I always do is just shake it, swirl it a bit gently, and then you need to open the...
Yeah.
This one's okay, really. It shouldn't build up any gas, but the idea of releasing that and opening the the hole, or the tap, is so that if there's a pressure build up in here, anything will escape. And the next step that you'll be doing involves adding sodium carbonate solution. And we'll just let that settle, and we'll see what eventuates after a few minutes.
This one's less dense and this one's more.
That looks wicked.
And that lower part would have gone into this and mixed with the water. So all of your non-polar layer stays at the top, and then the water mixes with the polar layer there.
Yeah.
The aqueous layer is drained out, leaving only the organic layer containing the ester. Calcium chloride is added to soak up any extra aqueous layer. Boiling point properties are then used to collect off the different layers. As the mixture of reactants and products are still in the organic layer, we need to separate these out. Distillation is used to do this.
And what temperature are you at?
130 to 135.
So what does that mean we're collecting?
Everything about the ester, hopefully. To the ester. You don't want it to go up to 40 because then we might lose some of the ester.